Welcome back. This is section 9.5 on kinetic energy, and this is section 8.5 in your textbook. Kinetic energy is the energy due to motion, and this screen is actually important because it gives a couple different definitions that may help you. It's the energy that it takes to bring an object up to speed. If you're going to have an object that becomes moving fast, whatever energy it took to make it move fast is its kinetic energy. Also, if it's going fast and you slow it down or stop it, that's the energy it takes to stop it is exactly the same as the kinetic energy. So the energy is either the energy it takes to get it going or the energy it takes to stop it once it is going. The formula for kinetic energy is 1/2 mv squared. So mass is your m, and then the square of the velocity. So the speed of something will determine its energy more than its mass. So if something is going, say, 2 meters per second, then that 2 will, if you were to move it from 2 to 3, okay, let's just fill it in. Let's say you have one mass, and I have one mass going at 2 squared, okay, and so if you were to say the kinetic energy here going at 2, it's going to be 1/2 of 4, which is 2m. If I make it go to 3, okay, so the kinetic energy going to 3 would be 1/2 m3 squared. That would be 1/2 of 9m, okay, which is 4.5 m. So you can see by going up from 2 to 3, you've actually increased its energy more than twice. To move it going up 1 meter per second would make its energy more than twice. So it is relying on its mass. The bigger the mass, the more energy it has. I would rather catch a wiffle ball than a bowling ball, but the speed also would determine how much energy it has. It's also important to remember that the energy that you give it is equal to the work that was done to get it that way. So if you do work on an object, okay, by moving at a distance, okay, work, remember, is force times distance. You do a force on an object at a distance, you can give it some energy. So let's say that I push a ball, throw a ball, I'm giving it a force at a certain distance and then release it. Its kinetic energy is directly related to the work that I put into the ball by making it go fast. So I could find the newtons of push, I could find the distance over which that force was applied. There's all kinds of questions I can answer if I substitute for kinetic energy. It's equal to the work, and the work is equal to the force times the distance. So force times distance equals 1/2 mv squared is a different way of doing this formula. So if you double the speed, you've quadrupled the energy. That's why that it's important to, when you're driving behind someone, to stay at least a couple car lengths behind, because if someone is going fast, the energy that they have is directly related to their speed. So for you to try to stop your car, if someone stops ahead of you and you're moving, to try to stop your car, you're going to have a distance. Remember, you've got a force, the force exerted on the brakes, times a distance equals whatever kinetic energy that you have. So the faster you're going, the more distance it takes to stop. That's why you don't want to be right on top of someone, because if they were to stop, you will buy their car. So how are work and kinetic energy of a moving object related? The work required to make it move is equal to the kinetic energy, or the work required to stop a moving object is equal to its kinetic energy.